the first part, which we're gonna talk about today, is serverless, and the second part we're gonna talk about machine learning services on AWS. So yeah. So if you remember, we had a previous session on Lambda, and we knew like we took a little bit on Fargate. I've showed you like a website on serverless. I'm gonna show you it again. So let's do a quick recap before entering anything. So when we say serverless, which is less servers, that doesn't mean in programming it's not equal, so not equal to there is no servers. So there is servers, but you don't manage there is no server, sorry. So when we say serverless, we don't say that there's no servers. We say that we don't manage them. So only we get what we want, okay? We don't control the scale. We don't control anything that's underlying. We just control the service, and the screen is not showing. Why? Let me share it again. Okay. Here. Okay, so again, when we say that serverless is not equal that there is no servers, there is servers, but we don't manage that. So we don't manage the scalability of these services, the performance, the functioning. We only care about our business need in general. So AWS have its own website, which is called Serverless 101 or Serverless Land, as you can see here. And you can check out these services, which is Lambda, API Gateway, Event Bridge Pipes, and Scheduler, S3, and step functions. As you can see here, there is a lot. You can see Kinesis, DynamoDB. Like, there's a lot of services that are serverless. So let's start. We're going to give a brief introduction, services, use cases, benefits, and some best practices. I may leave the use cases till the end. So we may talk about introduction, services, benefits, and best practices. Then we're going to talk about use cases, because the use case part is we have a problem and this problem or a use case, and then we're going to get the solution, and then we're going to talk about the benefit of using serverless. So it's going to be a little bit long, and it's the most interesting part. So let's get into it. Introduction. So firstly, we've talked about serverless. It's a shift. It's a huge, humongous shift in the cloud architecture. You can only build and run application without the need to manage servers, as we said. And cloud provider dynamically manages the allocation of machine resources, allowing developers to entirely focus on writing application logic. So, based on that paragraph, we can say that serverless allows developer to focus on business logic. So, business logic serverless. يعني أنا مثلا صاحب شركة، هذا الإشي بيفيدني لما أنا أكون بدي أكتب يعني الإشي اللي أنا بحاجته، يعني ما بدي أتحمل مسؤولية أشياء أنا مو بحاجة أتحملها. So, services, a lot of server. Okay, so the first thing we've talked about is Lambda. We gave a session on Lambda, and it allows us to deploy code, and deploying the code and triggering it by functions. Like, you can set up trigger and it can function. So it allows you to run code in response to various events or various triggers, as we can say, and it can help us a lot. So this is it's not pay as you go, it's pay as you use. Okay. So the difference between Lambda and EC2, if it's 24/7, you're gonna pay 24/7. Lambda, you're gonna pay for the things you use. So if you got like three triggers a day, you're gonna pay for that 3 triggers, and that's it. And you can leave it on for like forever. Okay, API gateway, it's the front door of applications. It can provide a unified interface to access backend services such as Lambda function, EC2 instances. Okay, so API gateway, let's imagine we have an architecture, like a really basic and easy one. So we have like this domain. So DOM domain, and then we have like Lambda, EOB, load balancer, maybe EC2. Okay. So API gateway, or here you can see, wait, fix that. So API gateway will give us like a front door so we can manage all these kind of back-end services. So if we went to API gateways and we went to resources using serverless LAN, you can see here we can create, manage, and secure APIs. It has both RESTful and WebSockets, these in front end. I'll try maybe let's guides, let's see guides. And let's try and check out API gateway. Okay, here you can see API gateway. I want something API gateway. Oh, I want something very easy. So building API platforms. We can check on view guide, and you can see here that it's gonna give you a full-on guide. So develop, test, a lot of things. Okay. So the next thing we have is a step function. So let's imagine we have a workflow. Have you ever taken problem solving? So you can either problem solve using a workflow or and a Sudoku. Okay. So let's say we have this workflow, and maybe okay. So let's say a customer came in, ففي عنا زبون بده يدخل على coffee shop. So this function right here checks if it's open. So is open. If it's open, you can enter. So T enter, and if it's not, you can exit. So you can see this this workflow. تروح انت على coffee shop, we start from here, then we go down this function, check if the shop is open. If it's open, enter. If it's not, exit. As you can see, this is a workflow. Maybe we can continue, like he can order or he can exit again. Let me fix that, sorry. So either he can order, sorry for the writing, and then we can say like pay or exit, like a lot of stuff. Okay, so this is a workflow. This is used by step functions. Step functions gives us the ability to make workflows and connect services using it. So you can see here, step functions allow you to coordinate multiple AWS services into serverless workflows, which is making it easier to build complex, long-running processes, and it manage execution flow, error handling, retries, and parallel processing. So these, the flow and execution flow and error handling, same thing as if the shop is open, exit or enter. Yeah. So this is step functions. It's literally like let me close this. So let me put like step functions. Sorry, it's stuck. So step functions, AWS. And I'm gonna show you like an image. You can see here how does it work. Okay, that's like huge. I want something. Okay, as you can see here, this image. Maybe let me try and copy it. So why am I doing this to myself? I don't know. Let me go down. X. Okay, great. So as you can see here, it's literally a workflow. So you start here, prepare data, process data, and you can parallel, you can insights using parallelized step, data insights. So this is step function. You can see a design workflow. Can use a lot of things. Okay. DynamoDB. We've talked about DynamoDB. It's a serverless NoSQL database. It's highly scalable and it's used for a low latency. It's used for stuff like social media inputs. And you can see here, and its serverless nature ensures that you don't need to worry about database admin tasks. We're gonna take it in our database. And we've talked about also AWS S3 bucket. It's an object storage where you can upload binary data or blob data, texts, images, videos, documents, binary text, whatever. And it can scale up and down, can scale based on your business needs. So it's very high available, it's very durable, it's very secure. And last but not least, AWS Fargate. It's a part of container services where it's a serverless container. Okay. And we've talked about it. So we said use case, we're gonna leave it till the end. So let's go past use cases. I have like 5. Then we're gonna come back. So benefits. It's cost efficient. As we said, it's pay per use, and we've talked about this. It's scalable, so you don't manage any kind of scalability, and it can handle it by its own, so without any manual intervention, and reduced operational complexity. So what do we mean by this is we have no server managed, so that's gonna make us more relieved. We only have to focus on the things we need. Faster time to market, of course. Just imagine deploying a Lambda code that's gonna run every time it triggers. It's high available, of course, because we don't manage these stuff, so it's built-in resilience, and it's secure. So it has multiple security features that are integrated, like IAM, encryption, network isolations, and a lot of stuff. Okay, so best practices. We can design for event-driven architecture. We've talked about event-driven architecture in SQS and SNS. We can have what's called asynchronous processing, and we've talked about asynchronous and synchronous. And just like to memorize, you guys, event-driven architecture is based on an architecture that runs on events. Okay, في عندنا حدث، وهذا الحدث اللي بيخلي هذا الايفنت يتحرك، يعمله deploy process. Okay, optimize Lambda performance. So we can use how do we optimize Lambda performance? Just so you know that Lambda cannot operate over 15 minutes. So anything that takes more than 15 minutes, you should like consider using Lambda. Doesn't take like a lot of size. So as much as you can minimize the size of your Lambda deployment packages by only including the necessary dependencies, and it's gonna reduce cold start times and improve execution efficiency. And we've talked about cold starts and warm starts. Use infrastructure as code. So we've talked about infrastructure as code, kind of like Elastic Beanstalk and CloudFormation. And IAC is like a picture that contains all the code of our system, and you can like take that picture and deploy it multiple times. So in AWS is AWS CDK or CloudFormation. A third party is Terraform. You can use Terraform as IAC, and version control like Git. So implement securities and best practices. We've talked about the least privilege, so giving the minimum permission necessary to perform its task. Encryption using KMS, VPC integration, so virtual private cloud, and it's going to help us control the network access. Okay. Monitor and optimize. Again, we've talked about monitoring. Remember, CloudWatch, monitor CloudWatch, and API trailing is CloudTrail. And X-Ray was one of the monitor services we didn't talk about. So you can see here X-Ray for monitoring. It can be used to trace and debug Lambda functions, but we haven't talked about that. Handling cold starts. We've talked about cold starts and warm starts. And we've talked about the warm start costs more than cold starts. And the difference is a warm start, you're going to use the already initialized container, but cold starts, you have to reinitialize a container to do that. Enable API gateway usage, so caching and rate limiting and throttling. So caching, we've talked about caching is having a copy of something. Implement rate limiting and throttling to protect your API from abuse and ensure fair usage across clients. So let's say I can give a client like 10 usage or 10 rate limiting, and that's it. If it goes beyond 10, just block that client, because some client will use that to hack your system. Use DynamoDB effectively. We've talked about capacity planning. So if you have something that you know you're gonna use, if you have an unexpected workload, you can use like burst mode or stuff, and you have the provision mode where you know what type of things you need, and indexing. So let's go back to use cases. And why am I going back? So let me go back to use cases. But before going into use cases, في حدا عنده أي سؤال؟ في حدا عنده أي استفسار قبل ما نفوت use cases؟ Okay. So use cases. We have 5 use cases. We have a problem, we have a solution, and then the benefit of the doubt. So file processing scenario عنا, we have a media company that needs to automate images and upload as soon as they upload, process images and videos as soon as they are uploaded by users. ففي عنا شركة, هاي الشركة بدها تعمل process للفيديوز والimages, ممكن حابة مثلا like to label the images, let's say, and videos. So let's say إنه في عنا clients عم بينزل صور لشجر يحطوها بليبل شجر. Videos of cars, label them cars, and these type of stuff, like maybe this kind of processing. فبدنا هذا الاشي يكون automated, أول ما ينزل الكلاينت أو user image دغري نعملها process. So we can use S3 that triggers a Lambda function, and this function can resize, transcode, or extract metadata, and then you can get this data and store it in another S3 bucket. Okay, so again, كأنه شركة بدها تنزل فوتوز فيديوز، أول ما ينزل هدول الفوتوز والفيديوز بدنا نعملها process. So reading the scenario, we need two things. We need a place to store the data or the images and videos, and we need something to process them. So for storing the images, we can use S3 bucket because it's an object storage. It stores images, files, documents, a lot of things. And to process these data, because they're gonna take less than 15 minutes, we can use Lambda functions. So benefits, instant processing, every time we upload something to S3, it's gonna trigger a Lambda function to run, and it's scalable, and you're only paying for the compute time used. Imagine doing that on EC2 instances. You have to keep it running all the time, and you're gonna pay for the time you're running, even if you're using it or not. So use case number 2, serverless web application. So I think this is wrong. Yeah, this is wrong. This is okay. So let's imagine we have a web application. I'm gonna fix this, guys, but let's imagine we have a web application, and this web application has like a lot of backends, and we need a way of handling these backends. So based on the thing we said, we can use API gateways to expose RESTful APIs, and AWS Lambda to handle business logic, and Amazon DynamoDB for storage, and S3 can serve as static content, and CloudFront can distribute it globally. Okay, so using web applications, which consists of a front tier, back tier, and the data tier, API gateways can help us manage the back end by exposing RESTful APIs, which is like a link, let's say a domain. AWS Lambda can handle the business logic, and Amazon DynamoDB for data storage, and S3 can serve as static content or maybe a static website. And CloudFront, we've talked about edge location and computing, can distribute it globally. So Benefits, we can high available, automatic scaling, and cost-effective pay-per-use model, of course. So use case number 3. We have a financial services company needs to build a microservice architecture, and we've talked about microservices that can handle events such as transactions, fraud detection, and customer notification. So عندنا شركة مالية بدها تعمل application بس microservice application. So microservice decoupling architecture, we've talked about this. So, parts are not dependent on each other, ما بتعتمد على بعض. They can handle various events. ففي عنا أكثر من نوع من event. عنا transaction، عنا fraud detection أو كشف الاحتيال، والحوالات، customer notifications. So we can use microservices like AWS Lambda. We can pass the services, or we can pass the notifications using SQS, SNS, or Event Bridge. We haven't talked about Event Bridge, but we can use SNS and SQS. And step functions can orchestrate the complex transactions, fraud detection, the thing we need across multiple microservices. So Lambda to handle the events, and to events being passed around other services, we can use SNS and SQS. And step functions is just to demonstrate how complex workflows can be done. So benefits, we're gonna decouple our services. It's gonna be easier to scale and simplified maintenance. Use case number 4. We have a data analytic company wants to process and analyze large data sets in real time. So if you remember, guys, when we've talked about data analysis and like data analysis and large data sets, do you remember what service serves that? We've talked about data analysis, 4 types. Okay, so a quick hint, it's Kinesis. It's not a hint, I give the answer. So we can use Lambda functions triggered by data uploads in S3 streams or streams in Kinesis. And this process data can be stored in DynamoDB or Redshift. So Redshift is a data warehousing we're going to talk about later, maybe on. So every time data is streamed through Kinesis, it's going to trigger a Lambda function. And data processed can be used in DynamoDB or Redshift. Okay, use case number 5. Oh, real-time processing, reduce operational overhead, and the ability to handle large or big data. So use case number 5, a company that manufactures smart homes. Device need to process and respond millions of data of millions of devices. So we have a company that manufactures smart home devices, needs to process large amount of data that's coming from millions of devices. Of course, we can think of Kinesis, can happen. And we have what's called an AWS IoT core. So we can use Kinesis, it's possible. We also have a specified service for IoT, which is the IoT core, and it can manage connections of devices with the cloud. And Lambda functions can trigger to make responses to alerts, and then process data. As we said, we can use a DynamoDB or S3 for analysis. Benefits, scalable data management, real-time data processing, and event-driven architecture. Okay, so let me open close this. I have this thing I made like a long time ago that talks about serverless mindset. Sorry. Okay, so hopefully I can find it, sorry. DNS cheat sheet, serverless mindset. Let me show you, let me stop the share and try to find it for you guys. So just okay. What? It's an MP4. No, I don't. It's an MP4. cheat sheet. Okay, let me guys get you the file. Stop sharing. I think I'm gonna find it on Canva soon. Okay, found it. Let me share my screen again. Okay, so serverless mindset. Let's begin. I made this like a long time ago. So we have a basic web architecture. We have a user, a web server as EC2, and backend as RDS or relational database service. So let's say, what if number of users increase? So we're gonna scale up the server, we're gonna add more CPU, we're gonna add more storage, and then these users can be served. But what if the instance fulfilled its capacity, so we no more can add more CPUs or storage? We're gonna go to what's called a horizontal scaling. This is vertical scaling, by the way. This is horizontal scaling using elastic load balancer and web servers. So we need to manually provision servers, time and cost consuming, because let's say if these three are full, then we have to add more instances, which is manual. Okay. So we add an auto scaling group. It's going to be more time and cost efficient, and you can upload the auto scaling group across multiple availability zones for high availability. So important thing to consider with these architectures is you have to manage the infrastructure like operating system patching, runtime, scaling, recovery, latency, capacity planning, and health checks with load balancer. You want a solution to manage your application and code, then that's it. You don't want to manage the operating system patching. So serverless architecture, there is a request, business load, logic, and backend. So event, and something to handle that event, which is called a handler, and a backend. So we have an event, Lambda function, and DynamoDB. So we're going to write the code, then we're going to deploy the Lambda, and code will run in response to events. So in serverless, there is no server managed. We have automated high availability, flexible scaling, no capacity planning, and no idle capacity is used, and you pay only for running the code, and that's it. So this is the thing I wanted to share. It's like the cherry on top. So let me stop the recording.